Hello! You're in for a treat.
Tuesdays and Wednesdays and Thursdays.
2 West.
6 to 7:30 p.m. Eastern Time.
We got new hours because we're nerdish.
And we're in our 20s despite our looks, so we gotta do things in the evening time over the summer.
Correct, but not too late because, as Levi said, we're in our mid-20s.
Not our early 20s.
And not our late 20s, the mid-20s.
So, yes, we're the Goldilocks of 20s.
That's right, I shouldn't have laughed. I gotta keep it cool, because this is our intro rap, where we keep things cool.
We're very cool, so cool we might want a dance break.
Hey, thanks for watching our dance break.
Now, back to the really serious stuff.
Like Brady
And Levi.
and Brady too. We're the 3 members of the Nerdish crew.
That was perfect. We didn't plan that.
Not at all. We don't plan anything. If you couldn't tell by this rap. That was the one thing we rhymed.
That was the one thing.
Which makes it a rap.
Yes, all raps have one rhyme.
We'll see you on 2 West.
Yes, 2 West.
6, 7:30 p.m.
Eastern Standard Time.
Keep watching, because it'll turn into us, but probably not wearing the wigs.
Yes, and we'll be much more responsive to whatever you have to say.
You could ask us questions right now. We will not answer them.
Also, we take no responsibility for anything we've done in this pre-recorded session.
Yes. Any lost items, Nerdish is not responsible.
Right, we don't have anything to do with it. We're very different people in the present than we are from when we're recording this video. You might say we are the pupae of Nerdish right now, and in the future we will be the moths.
The
Because moths are the
disgusting
most-
gray moths.
Yes, those gray moths that you hear, they're like the bats of the flying community.
The wings are leathery. They're leathery wings.
Very leathery.
They're basically butterflies, but we hate them.
Yes.
They're the rodents of butterflies.
This is true.
Right?
Just like the ACT is the rodent of the SAT.
I don't agree with that. I don't agree with that at all. Excellent.
Very good.
Very good. That was our new intro.
So good.
Starring Levi and Brady.
I don't think anybody knows.
Well, they'll see it when they watch this later, hopefully.
Let's see it when they see it.
Yeah. We had that Batman up for a while, and like someone finally saw it and was like, "What is this?" We're like, "We've
Yeah.
had this up for a month."
What have you been doing?
Seriously. Seriously. I didn't restart that. That's good. That's good. Like Brady and Levi and Brady too. We're the 3 members of the Nerdish crew. So,
All right.
Oh, all right. We're heating up, man. We have twice the viewers that we had like a moment ago.
Yes, that's very true.
Yeah.
Oh, I need everything.
Oh.
So. Oh no.
Hello, Hono.
Oh, no.
How you doing? You doing well, Hono? Hono's a girl. I was just thinking.
Oh no! Did you know?
Yeah. Hono, you are a girl. You might not have known that. Again, it's like Hona would be clearly a girl. Hono makes it a little more difficult.
And by saying hello, she's addressing us as boys because it's hello instead of hella, which is where hella comes from.
That's where hella comes from. It's the feminine hello.
Reading for
Yes.
women.
I'm doing a college course this summer, and I didn't realize college was this difficult. What are you taking, Hono? Where are you taking it? How often do you guys meet? I like the intro.
Nice.
Ray Matthews. Ah, there we go. Good.
Very nice.
It's a new one. It's a new one. We put a lot
Very
of work
new.
into it. We actually
prepared
did,
for
though.
that for years.
Yes. We tried to record it many times. And we
Yes.
kept encountering different technical difficulties. And each one was very different. We finally ended up with that one.
Yeah. So that'll be on the test.
Oh, yeah, definitely. The test. It's at Syracuse. I'm doing pre-med every day from 8 to 4. It's the biggest pain ever. Wow.
What pre-med are you doing? Science-related pre-med stuff?
Pre-med at Syracuse. Jeez. Now, is Hono now in college, or is Hono going a senior year?
Hono is.
Hono wouldn't have been watching us if she was already
No,
a
no.
senior.
Hono's taking a college course.
This summer,
Yeah.
and then going into senior year. Yeah. Interesting. So, like, Yeah, is it just like pre-med the whole day, or is it like breaking it up into like, now we're gonna talk biology stuff, and then later I'm gonna be a senior this year. This is just gonna get my resume good.
Elmo.
Yeah. That's how you say that.
Oh gosh.
Yeah. Oh, that's excellent, Hono. You need any help with any of that pre-med stuff? Levi and I are pre-med.
Yep.
I guess we passed med, like passed the opportunity to do med.
Yes.
We could always
Post-med.
We're post-meds.
I guess dead
exactly.
people are post-med. You know?
The medical community could not save them, for they are dead.
And more people are dying now than
Ever
used
before.
to. Yeah.
In human history.
Exactly.
That's pretty amazing.
Yeah.
You know, I
We gotta
was
fix
listening.
that.
You're right. I
Yeah.
was listening to this.
No, you weren't.
Yeah, you're right.
Yeah.
No, it was YouTube. It was Crash Course.
Oh.
And he said it's only the past 10 generations where you could confidently expect that your quality of life would be better than your parents. Only the past 10 generations. And there have been like, how many generations? Hey! It's Manal!
Hi, Mono. How are
Monal,
you?
Sorry. Hi, Monal. How's it going?
Mhm.
Very good.
Yes.
Okay. You need any help, Monal, with ACT or SAT? So we got you covered.
Oh,
What?
I owe you a test.
You got to send it.
Yeah. Well, no, I will.
Okay.
Yeah.
So, Hono, when are you taking the ACT or SAT next? I believe there's an SAT soon.
23rd.
23rd?
I think.
Oh, of August.
Yes.
So we don't have anything for a while. Did I ever tell you guys I did really good on my ACT? No.
Wait, no, you didn't.
No, you did not.
You told us you weren't happy with the SAT, right?
How did you? Oh, now wait. Did you tell us that you did well on your ACT? That's what you should have
Well,
said.
maybe she did good.
Oh, maybe she did really
maybe
good.
she like put it down on the floor and then she like.
Ooh, look at that.
Oh,
A
nice.
clean 30.
That's a very
Dude,
clean 30.
That's a clean score.
Where? How do you know your score? Or
They
what
probably
ACT was this?
sent them a report.
Oh, the report. I never knew they sent reports.
Yes, where they tell you what scores you got.
I thought you just take it.
Okay, let's see. Okay, here she's taking the SATs in Nove.
Very good.
Good. That's going to be a good one. Oh, no, that's fantastic.
Yeah, good job, Hono.
Well done.
All right, we have some robot dancer questions.
Oh, we do?
Yes.
Why don't you just kind of put them up, you know?
I will. Robot dancer put a screenshot of an old thing and wants to talk about it.
Let's see.
So that's what we're gonna pull up.
section every week. Usually one he wrote himself.
Bam.
I look like stupid in the back. Oh, this is confusing now. Like, I don't know how that corresponds onto my 1150 on the SAT. I don't know off the top of my head what the concordance tables say.
You're cut off, by the way.
Oh, okay. Hono, do you know what 1150 would be? Because there, you know, if you just look up ACT, SAT concordance tables on Google, then it'll very quickly tell you like what each one means in the other test.
Okay, I will tell you right now.
Should I look it up?
Yeah.
All right. So the question that is, Robot Dancer's not here yet.
Yeah, but we can do. I don't think. I think Robot Dancer's probably asleep.
Where does Robot Dancer live? You think Robot Dancer's? I mean, you think
sort
Robot
of
Dancer
recall
is
that happening.
recharging?
Yes.
Where he/she
Yes.
is a
Robot Dancer is now wireless chargeable.
Wow.
Yeah.
Huh.
Just lies down on
A
a
30
plate.
on the SAT is a. Oh wow. Yeah, let's stick with the ACT for you, Hono. Don't even worry about the SAT anymore. That's just not your test. Yeah, ACT is absolutely
Oh,
your
yeah.
test. Yes.
ACT for Hono all the way.
All the way.
That's
Yep.
much better.
I would stake my life on that.
Yes.
Yep.
All
Very
right,
good.
So yes. And that's
So okay, so
also-
Robot says what about this?
Okay, so Robot's asking about commas, and that's what the next question is as well. So I assume Robot. Let's just think.
Robot's
so
not
it's-
here.
I know it's just about 7 minutes in, so I'll send him the timestamp of this. Okay, so this question here, we were talking about some question. I think it was on the SAT. No, it was probably on the ACT, given those answer choices. He began including
A word cross.
a word cross in his section every week. Dash. Usually one he wrote himself. Why did we write Fahrenheit 451? Who knows? Then we have F, G, H, and J.
I don't know why J would be or F would be wrong, honestly.
What's the difference between H and F?
Oh, you know what? I probably crossed off F and changed the actual sentence to G's answer or to H's answer. That's my
okay.
guess.
Okay.
So what's written up there is correct, and that the reason why you wouldn't put a comma is you could put a comma. I think that was your question, Robot. You can put a comma. It's just not one of the answer choices here. I'm pretty sure. A comma would work here totally fine because he began including a word cross section in his section every week. That is an independent clause. Then we have a little bit of a non-essential that's describing his section, right? It's the word cross. He included a word cross every week, usually one he wrote himself. So because it's a non-essential element, it's not an independent clause, so you don't have to use a semicolon like in J. I don't know what F was. And then you wouldn't put and because you're not listing things with an and that are at the same level. We are describing one thing as the other, so it's a non-essential. You could use a comma here, you could use a dash. One of those is correct.
Excellent.
Generally err on the side of commas. They're a little bit more common, but in this case you only have the dash. Okay, I'm going to pull up the next one if you want to do the next one.
Absolutely.
Also, anybody else watching, please ask your questions in the Discord or in the chat.
These are all grammar questions. Grammar
questions.
Grandma questions. These are all grandma questions. Levi, crop it.
I'm going.
Crop it. I like it when you crop it.
I know you like it when it's cropped.
You know me so well.
I do. I'm just a good listener.
Yes. I like it when Levi crops it like this. This is what I like when Levi does what he's doing.
All right, can we read that?
Oh, make it big. All right, so this is number 16. Okay. So I'm going to read two sentences before this. So it's going to start with dogs, pigs, cows, rats, and even flies and caterpillars were arraigned in court on charges ranging from murder to obscenity. The trials were conducted with full ceremony. Evidence was heard on both sides, witnesses were called, and in many cases the accused animal was granted a form of legal aid, a lawyer appointed at the taxpayer's expense to conduct the animal's defense. Wow, this is a goofy situation because they're bringing animals into court. All right, so your question is, why is it A? Otherwise you wouldn't have asked this question. That is a good question. Why don't we start with D? We have a period after legal aid, and then we've capitalized the letter of the next sentence. You only want to use that if you're ending a sentence and beginning a new one. In this case, the new sentence we'd be starting is, a lawyer appointed at the taxpayer's expense to conduct the animal's defense. That is not a sentence. A lawyer appointed. That right there, you'd think that's the subject and verb, but that's not an active action. You could say a lawyer is appointed, and then you've got yourself a nice active verb and you've got a sentence. But a lawyer appointed at the taxpayer's expense is just a description of legal aid. So this is a non-essential. It can't stand alone, so we cannot have a period there. C is the same problem, which is a lawyer appointed at the taxpayer's expense is also not a sentence. You do not want to start a sentence with which in that form, which is a blank. That is supposed to be added on to the previous sentence as a non-essential at the end. Kind of like, I mean, they could use C. I'm sorry. If they took out the period in C and have a comma instead, and then say which is a lawyer appointed, it wouldn't be the best way to punctuate this sentence, but it wouldn't be terrible. So we'd say the accused animal is granted a form of legal aid, which is a lawyer appointed at the taxpayer's expense. That would be fine. The thing is, we don't even need which is. We know that they're describing legal aid when they say a lawyer appointed at the taxpayer's expense, because that's one of the things we often see commas used for, is separating a word from a description about that word, which is what's going on. B is it's a very different problem, actually. So they're creating a second independent clause when they say this is a lawyer appointed at the taxpayer's expense. So now that we have a second independent clause, we have to separate two independent clauses. And all they're doing is separating it with a comma in answer B, which you cannot do. The four ways you can separate two independent clauses are comma fanboys. You got to have both a comma and a fanboys. The fanboys are for, and, nor, but, or, yet, so. You could use a period. Of course, that's the one you see most often. You could use a semicolon. Semicolon, the only thing it does is it separates two independent clauses. Or you could use a colon. With a colon, you need to have an independent clause before, and you could have anything you want after, including, but not limited to, an independent clause. So B is still a run-on sentence because it's not separating two independent clauses correctly. Levi, you want to do the next one?
Oh my gosh.
Does that mean yes or no?
It does mean yes.
Very good. Do you want me to crop it or do you want to crop it?
I'll crop it.
All right. I do like cropping it myself sometimes.
Do you?
Yeah. You mind if I crop it?
Yeah, go for it.
Very good.
I don't mind. Okay. The next one, I think, is also a similar type situation.
Oh, Robot asked why is the comma kept? Okay, because it's a non-essential at the end. All right, sorry, keep going.
Commas are generally non-essential. Any most difficult comma questions are non-essential commas.
Now, Levi.
Yes.
Take a look at this question first before
Why?
we.
Okay. No, I checked it before.
Oh, very good. All right. So I gotta wrangle this thing.
Mm-hmm.
I gotta wrangle it.
All right. Brady's practicing his cropping skills while I'm practicing my. What is that word called? Brady, what's the name of that word?
Waiting.
When you're stalling. I'm practicing my stalling skills. Clearly, I need work. Thank you, Matthew. Exactly. Matthew got it.
Very good, Matthew.
Dang it. Oh, I can't think of those words. Can you make it... Can you cut off the top there?
Yeah, I can.
Ooh, yeah, that's perfect. Okay. So, we know that often we have DC, comma, IC, right? And generally, you would have IC, DC, like that with no comma there, right? So if we have the sentence, this is the normal one, I walk while I whistle. That's this one. Independent clause is I walk. While I whistle is our dependent clause. If you invert them, you're going to get a DC, comma, IC, which is while I walk, I whistle.
Yes, but Levi, this is going to be the opposite. Of
Yes,
what we think.
I know.
Yeah. Okay.
So this is how it normally is, and for the purposes of the ACT, this is generally what's going to happen. It's an independent clause followed by a dependent clause with no comma. The rule that we talk about with having DC, comma, IC is more important. This is a possibility, but in this question, the dependent clause, what we talk about normally is with a marker like this, like while. If you take that out, you have your subject, you have your verb. What we have up here is, and it's not absolutely necessary that you remember this term. I think it's an adjectival dependent clause. It's an adjectival clause, which means, yes, you do have a clause, but it's not the normal type where you have a clear subject and a clear verb. In this part where they've labeled dependent clause, we have all of which showed an inflation-adjusted real gain of $9 billion since 2000. Okay, so the last little bit right here doesn't matter at all to this piece of, this phrase. All of which showed. Showed is our verb. All of which is our subject, and it's not a subject. It is an adjectival subject in which it's referencing the earlier part of the sentence, and it absolutely needs that beginning part of the sentence, right? And that's why they're calling it a dependent clause. But it's adjectival, which means you can have the comma, and what we've talked about before, and if you want Robot to answer, we can talk about which versus that. When you use the word which, you want to generally have a comma before it because it is restrictive to specific pieces. If you have cars which are this, it's specific types of cars versus cars that are this. And that's separate mostly, so let me know if you want us to go over that, but you'll see this at some other time. So in the case of this sentence, were there answer choices here? No. Okay. So these numbers represented more consumer spending for dance, classical music, and non-musical theater events. That's our independent clause. Then we have a comma, which means that rather than see this, let's use yellow. Rather than see this as a dependent clause, I would look at it as a non-essential instead. So you can keep this rule happy in your head, but it's an independent clause, comma, then you have a non-essential. The non-essential being what they've underlined here. So all of which showed an inflation-adjusted new gain of $9 billion since 2000. Okay? Please send a message again if you have a question on this to follow up. But I would see what this is as an independent clause and then a non-essential instead. You don't quite have the normal type of dependent clause where it's a very obvious subject and verb, and then you have a DC marker. In this case, you have a verb very clearly, which is showed, and then you have an adjectival subject thing, which is all of which. And that's way more in depth than you absolutely need. I would stick with, you want this rule. That's the rule for DC, comma, IC. That's the use of commas. This one isn't one of the comma uses because there's no comma here. If there's going to be a comma, it would be that one, which is one of the ways to use a non-essential. If anybody else has any questions on that, please let me know. Okay. I don't think we have any more questions at the moment. So do you want to hop to factoring, Brady?
I would love to. I think it'd be fun.
Do you?
Yes.
Okay. So to clarify, what do we got? Wait, can you just have a dependent clause as a sentence?
No.
No, you cannot. So if we just have while I walk.
While you walk what?
What happens?
What
you
happens?
need something else.
Yeah.
This thing is the dependent clause marker. You can have I walk to school, or you could feasibly just say I walk. But I walk, I whistle, I jump, he sleeps, she runs, whatever it is, it falls down, it falls out the window, something like that. But if you say because it falls out the window,
that's why they call it dependent, because
Yes.
it cannot be independent.
Yes.
Very good.
Yeah. So Levi is a tutor, but it really that's an independent clause. But if we say because
Yep.
Levi is a tutor, it's a dependent clause dependent on Brady being a tutor, or Brady being a tutor is dependent on. Actually, that's a terrible example because that's very confusing. We say Brady is a tutor because Levi is a tutor. Then we have an independent clause, which is true.
Right.
Yes.
Yeah. I only do what Levi does.
Yes.
So he's a tutor, and because of that, I'm a tutor.
Yes, so the thing that, you can erase. The thing that separates dependent and independent clauses are their ability to stand alone as a complete thought and a complete sentence. They're both clauses, so you have a subject, you have a verb in both, like Brady giggles. But Brady giggles is an independent clause. If Brady giggles, you need something. If Brady giggles, a child is born, or something like that.
That's true.
Yes.
Children are born at least every minute.
Yes. You're doing factoring, yeah?
I'm going to do factoring, yeah. I'm going to do factoring. Yo, can I have this?
Nope.
All right, sounds good.
Can I?
I think so, yes. Anyone have a question before I jump into factoring? Because, man, when I jump into factoring, I jump into factoring big time. Big time. Here we go. All right. Just got to clean this guy off. This guy is dirty. So, very good. Very good. In case you guys are wondering, Levi is going to the bathroom.
Great.
What? It's true. They were all asking why you were gone. All right. Let's start with something funky. Okay? This is not really that funky, but okay, we'll just do this anyway. All right. You guys should all know this at this point, but if you're going to multiply two quantities together like that, you have to FOIL it. You have to multiply this by this, and then this by this, and you also have to multiply this by this, and this by that. So this will give us x squared minus 4x plus 3x minus 12. You can simplify to x squared minus x minus 12. The only reason why I'm bringing this up is because this gives us kind of a roadmap to going the opposite direction. Instead of foiling, factoring, where if we start with something like this, how do we go backwards to find out what the original factors were? So I'm going to start out with, let's go with x squared plus 4x minus 21. Before we do this, let's go back to this for a sec. This negative 12, where did that come from? This negative 12 came as the product of these two numbers right here, 3 and negative 4. That's where the negative 12 came from. The other important thing is the coefficient of this middle term, which is negative 1. The negative 1 came because we added together negative 4 and positive 3, which are these two numbers right here. So if you add together these two numbers, you should get your middle coefficient, and if you multiply them together, you should get your last number, which is the constant. So that's what we have to do when we're factoring. We have to think about two numbers that do the following two things. They have to multiply to this number, which is negative 21, and they have to add to the middle number, which is 4. So at this point, you have to figure out what those two numbers are. Because they multiply to a negative, one of them has to be negative. There's only one way that you can multiply and a product be negative, which is if one of the numbers is negative. Then they add to 4. There's an infinite set of numbers that add to 4. For instance, a billion and negative 1 billion, I'm sorry, a negative 1 billion and positive 1 billion and 4. You add those together, most of it cancels out, you just get positive 4. So you don't want to start with that. You want to start with the 21. If you can't think of what numbers are going to satisfy both these conditions, then just start with the multiplying one. How do we get 21? Some factors of 21, we got 1 and 21. We got 3 and 7, and that's it. So of those two pairings, which one looks like it's going to be a little more helpful? It's the 3 and 7. Because we can make one of those negative, and in so doing, give us two numbers that add to positive 4. So it's going to be negative 3 and 7. If you multiply, you get negative 21. If you add, you get positive 4. So now once you have your two numbers, you can just write out your two factors, putting those two numbers in. X minus 3, x plus 7. Okay? That is simple factoring in a nutshell. All right? Okay, where are we going to go from here? We should talk about some factoring patterns. Okay? Some special factoring patterns. This was just standard factoring. It wasn't really a pattern. But now we're going to talk special factoring patterns. Okay? So let's go x plus 5 squared. And grouping. Oh, complete the square and grouping. Yes. Why don't we just go straight to that? That sounds good. That sounds good. So a square trinomial. I'll give you an example of a square trinomial. This is a square trinomial. It's a trinomial because there's 3 of them. Three terms. All of these have been trinomials, by the way. This is a trinomial, but it's a square trinomial because it can be square rooted. All right? 36 is a square number because it can be turned into something squared. Something times itself. All right? You can break it up into 6 by 6. So can this, x squared plus 10x plus 25. You can break it into two factors, and the factors will be the same. Both of them are going to be x plus 5. So you can write it like that, or you can write x plus 5 squared. All right? So those are square trinomials. So the question is, completing the square is a situation. It's a way to solve quadratics. Your instinct to solve quadratics should kind of go in this order. See if it's factorable. Factorable is kind of the cheat code to quadratics. If you can figure that out, you'll find the answers very quickly. If you can't factor it, then it's kind of a toss-up. It's kind of a toss-up between quadratic formula and completing the square. It sort of depends on the way that it's set up already. Here's the end goal of completing the square, is you want to end up with an equation that looks kind of like this. We'll say x minus 6 squared is equal to 49. Usually when you solve a quadratic, you want to get everything on the same side and put it in standard form. And standard form looks like this. Ax squared plus bx plus c is equal to 0. That's typically where you want to go. Hey, get some sleep, young man. I know, King. I try so hard, and yet I don't ever get enough sleep. That's kind of a lie. Sometimes I get enough sleep. Yeah, it's been a long day. It's been a good day, but it's been a long day. Anyway, thanks for looking out for me, though, King Does Blender. We're not gonna FOIL this out and then put the 49 over and get it all into this form because it's actually in a pretty convenient form already. If we take the square root of both sides, it's going to get very simple very quickly. Okay? Take the square root of this, take the square root of this. This will cancel out the square, leaving us with just x minus 6. And then when you take the square root of 49, don't forget that you're taking the plus or minus square root of 49. So look at you plus or minus 7 right there. All right. Lastly, you just have to add 6 to both sides. These parentheses no longer matter because subtraction inside parentheses, if there's nothing that's happening to it after that, it really doesn't matter. Now you just have to add 6 to both sides. So x is going to equal two different answers. One of them is going to be if you started with -7 and you added 6, or if you started with +7 and you added 6, which is going to give you -1 or 13. Those are two possible answers for what x is. And the reason I show you that is completing the square is setting it up to be in the form right there. That form is something like this. X minus a squared is equal to b. Now don't confuse this. These letters a and b, these constants, don't correspond with those. I just made these up right now. But because you can take the square root of both sides, this is a clean way to solve a quadratic. But getting it there in the first place, that's what completing the square is. We have to get it to that form, and then we can solve it with that. So here's how you complete the square. Let me get rid of some of this stuff. Get rid of that. Times when this comes up is conics. If you've got some kind of conics equation that's not in standard form, so you don't know what the radius is or where the center coordinates are, you're going to need to complete the square to go back in time and find out what the general form was. Looks like I've got like a big kind of spaceman tank on my head. A spaceman tank.
A spaceman tank.
A spaceman tank.
Right?
Yeah, absolutely. I didn't let it dry. You gotta let it dry, Levi.
I know. I always forget that when you're doing it.
Right. Oh, fantastic. Fantastic. All right, so a square trinomial has to be a square trinomial. And what I mean by that is it has to follow one of these two patterns. So if we just take x and we add a to it, we square it. This is going to be a general formula. If you square that and you FOIL it out, you're going to get this. X squared plus 2ax plus a squared. Okay? And then similarly, if you subtract instead and you square it, you're going to get x squared minus 2ax plus a squared. The only real difference is that we're adding 2ax and here we're subtracting 2ax. Okay? So here's where this comes into play. Let's give ourselves something like this. X squared plus 8x plus, we're going to say minus 10. Minus 10. All right. You look at this and you'd say, is this factorable? And the answer is no, it's not. Two numbers that multiply to -10 and add to 8, forget about it. All right. This is where completing the square is an option that you can take. Our question here is, what does the third term have to be to make this a square trinomial? It's not -10. That is not giving us a square trinomial. Okay. I'm going to move the -10 over the other side. All right. It's not the number we want. It's not the number we deserve. So if you add it to the other side, we're just going to get it out of the way for right now. How do we find this number? Well, if we go back to this option right here, 10 was double what we had inside the parentheses, which is 5. So if we want to find out what that original number was, we take the middle number and divide by 2. And that's how we get this number. And then we take that number and we square it, and that's how we get that number right there. Okay? So if you start with the middle term, so this is the 8. First thing you're going to do is divide it by 2, and then you're going to square it. Or more generally, if you take b and then divide it by 2, and then you square it, that will get you c. Okay? So 8 divided by 2 is 4. We square it, that'll give us 16. That is what should go here to make this a square trinomial. But when you do that, you can't just add 16 out of nowhere. You have to add 16 to the other side as well. Otherwise, you're just breaking the rules of the equations. All right? And the equation police will show up at your door, and they will arrest you. And they're going to take you to equation jail. And then you'll have to be taken to equation court. You'll get an equation lawyer provided by taxpayer expense if in case you don't have one. Either way, you don't want that to happen.
Yeah, you see everything that's wrong with the system.
Yeah, it's a terrible
system of equations.
Okay, the system of equations. Did you know that when you said the system thing the first time?
I was hoping it would work. And
Okay, it worked pretty well. Okay, so now that we have our square trinomial, we can put it back in parentheses. It is x plus 4 squared is equal to, this is 26. Now we've got it in this pattern we were talking about before. So if we take the square root of both sides, we'll get x plus 4 is equal to plus or minus the square root of 26. And then you just subtract 4. So plus or minus the square root of 26 minus 4. That will get you your x value right there. Okay? Oh man, I'm pretty close to getting to that box. All right. Ring Matthews, completing the square. I should probably bring up a question where you'd actually need to know how to do it. That would be a good thing for me to do right now. And so that is what I will do. My hands are tied. I have no choice in the matter. I must do this.
What are you doing?
I'm going to do a conics equation where you have to complete the square to figure out what the center coordinates are.
Would you like to do it, or would you like me to do it?
I'll only give you the equation, then you'll do it.
Okay.
How about that?
Can it be a circle?
It could be.
Although if we're teaching, I think it should probably be a parabola.
It also could be that. So you'd be putting it in vertex form?
Yes.
Okay. You probably want to talk a little about vertex form then. Do you want to do that?
Sure.
All right. In that case, let me think about this for a sec. Okay. All right. So we're going to say, yeah, that's what we're going to say. Okay.
Am I going to erase all this? Or no?
If you want to. Okay.
Take your time. Also, how's class today?
It was good, thank you.
Yes?
Yes. Okay. So this is the standard form of a quadratic, and what I want from Levi is to put it into vertex form. Wow.
Okay, so real quick about vertex form. This is the form of the parabola that gives you the vertex h comma k. That's your xy coordinate pair. And then this shows you if it goes up or down and how wide or narrow it is. If you want to talk about the translations of parabolas, let me know. They're the same as translations of circles. Translations of absolute value are all the same. Okay, so to get from here to here, we need something nice so that we just have one x term, or one x value here, and then that's it. So, I said that the wrong way, not x value. Whatever, I want to do pink. Pink is good. So, to do this, we want to change this piece of the equation into x plus or minus something squared. That will give us our x minus h squared. The y on this side is more or less going to stay the same. So in this case, we're doing the opposite of this. So if you look at this, this is x minus h squared, which would give you x squared minus 2xh plus h squared. That's what happens when you FOIL out x minus h squared. So we're trying to get from here to here, this pink stuff, to here, which means that our minus 18x is our negative 2xh. To get our h squared, you don't have to know exactly why this is happening, but maybe you can reason it out. I can also reason it out for you if anybody wants to ask. But we are going to add b over 2 squared, where b is 18. You could say it's negative 18. It doesn't matter because we're squaring it. Makes no difference. So adding b over 2 squared means we're adding 18 divided by 2, which is 9, squared, which is 81. So I'm going to add, not there, I'm going to add an 81. And that will look like x squared minus 18x, and then plus 81 here. And then I'm going to add a minus 81. And I'm going to do it right there. Now, there are a couple ways you can look at this. If we're adding 81, we have to add 81 to both sides to be allowed to do that because we have an equation. But I'm just going to add 81 and then also subtract 81 from the same side. It's as though I had this 81 added over here and then I just moved it over. So I just did it all at once because we know that we're going to have a y by itself at the end anyway. And then we'll have a plus 98 at the end because that hasn't changed. Please let me know if this doesn't make sense. I have added 0 in pink, right? That's what I've added. That's why we add b over 2 squared to both sides, or add b over 2 squared, subtract b over 2 squared. Now, we're only looking at this, and we don't have to think that hard. It's going to be x minus 9. That's what it's going to be. It's going to be our b over 2. So it'll be, do I want to do this in pink? No, I don't. Do it in blue. We will get x minus 9 squared. And now we still have this minus 81 here from there. And then plus 98. That will equal y. And then we just combine these two. So we get y equals x minus 9 squared. Minus 81 plus 98 is plus 17. And then now we're done. That is our equation. It's clearly the same thing as this standard one here. Our a value is just 1. So let's graph it. Let's do it in yellow. Seems like nobody has questions. So that's
Well, he
good.
also wants to talk about Ring Matthews had a question about factor by grouping. Do you want
Factor
to
by grouping. Were you not doing factor by grouping?
Well, I haven't done it yet.
Okay. I can do it or you can do it. I taught it yesterday, actually.
Really?
Not on stream. I wasn't streaming without you, don't worry.
I hope not.
Nope, I wasn't. So here, our vertex is going to be 9, 17. It's 9 because it's minus h, so it's minus 9. The h is just a 9. So it'll be 9, 17, which is going to be somewhere around here. This is not going to be drawn super to scale. It'll open up because we have a positive 1, and it'll look pretty normal like that, where this point is 9, 17.
Oh, that's kind of fun. I kind of like that.
Yeah.
All right. I'm going to handle this.
Yes, my lord.
Absolutely. So factor by grouping is something you can do that's very fun. It involves getting yourself to 4 terms, which for this quadratic, which has 3 terms, there's going to be a step we have to do. A lot of students that I've talked to, their teachers just sort of say guess and check for these kinds of quadratics where you have a leading coefficient that's not 1. And there's no reason to rely on guessing and checking because that's only going to take you longer than it's going to normally take if you just follow what I'm about to show you. Like there's a straightforward method to getting there, so I don't know why they say guess and check. Most students start out with something like this. They say, well, I know it's either going to be 3x times 2x or it's going to be 6x times x. It's like, yeah, it'll be one of those, but I mean, if there was a number like maybe 36x squared, there are so many ways to cut that apart. You don't have time to try every combination. Okay, so here's how you solve these. Here's how you solve these. It starts out kind of similar to normal quadratics that have leading coefficients that are only 1, which is you have to find 2 very, very special numbers.
Oh.
Oh, all right. Now, normally these numbers look something like this. Here we go. Normally you say, okay, so these 2 numbers have to add to this middle number, they have to multiply to this last number here. As it turns out, there's a secret step you're doing that you're not even aware of, which is the 2 numbers don't multiply to this number, they multiply to the product of this number and whatever the coefficient of this is, which is, in this case, it's 1. So because the product of this and this is just 6, we don't even need to worry about that number out front, okay, until there is a number out front that's not 1. So we're finding 2 numbers that multiply to the product of a and c, which in this case would be negative 12. And then we're trying to find 2 numbers that add. Now this part is the same as before. It's just whatever that middle coefficient is, which in this case is 1. The 2 numbers that multiply to negative 12 and add to 1 are going to be positive 4 and negative 3. Now before you start making parentheses here, I want to say slow your roll. Slow it. Slow it. You're going to rewrite this equation. The only difference is you're going to, instead of writing the middle term, you're going to write the middle term broken apart into these two numbers. So it's going to look like this. Y is equal to 6x squared. Instead of writing plus x, we're now going to say plus 4x minus 3x minus 2. All right. The order that you wrote these two in does not matter. I put 4 and then -3. I could have done -3 and then 4. It would not have made a difference in our final answer. It'll just take us a slightly different path to get there. Now that we have 4 terms, this is where the factor by grouping part comes into play. All right. I like to put a little dotted line here. We're only going to focus on the first half first, initially, primarily in the beginning. That's redundancy right there. 6x squared plus 4x. You have to ask yourself, what kind of a person am I? Once you find that answer, then you could say, what do both of these have in common? What can you take out of both 6x squared and 4x? The answer to that is you can take out a 2x from both of them. If you take out a 2x, you're going to have 3x plus 2 in parentheses. If you can pull 3x plus 2 out of the second part, the second half, then your equation was factorable. If you can't, it was not factorable. You got to do something else. Can we somehow take out a 3x plus 2 from the second half? It depends on what we have in front. We want it to match what it used to be, which is minus 3x minus 2. In order for it to match, we're going to have to do this. Minus 1 times 3x plus 2. This minus 1 would distribute and make both of these negative, which is what we had up here, so this matches. Once you've got it down to that, this is one of your final terms, 3x plus 2. That expression is one of your factors. The other factor is a combination of what is out front of both of them. So we're going to group those together and say that's 2x minus 1, and then the other factor we already found was 3x plus 2. Okay, 3x plus 2. That works for quadratics. It also works for something that looks like this. We will say, okay, here we go. Okay. Okay. This is a cubic. You might say, I don't know how to solve a cubic. There's not a cubic formula. And you're mostly right. Depends on the situation. There could be cubic formulas for certain situations, but there's no general formula for quadratics. But we have 4 terms here. And if you see this on the ACT or SAT, especially the no calculator part of the SAT, they're counting on you to know that there's a way to solve this without a calculator, which is, this is factorable, all right? Let's just look at the first half. We have x cubed minus 6x squared. What do both of those have? They both have an x squared. If you take that out, now you have x minus 6. X minus 6. Can you take that out of the second half? We'll see. This is x minus 6. What would we have to have out front to make it equivalent to plus 2x minus 12? We'd have to have plus 2. This will give us plus 2x and then minus 12. So this was factorable. And now we're going to write these terms that are out front in their own set of parentheses so that they have a little home. And then x minus 6 is our other factor. So this right here would be the factors. And then if the question was like, what are some solutions? You're going to have 3 different solutions here.
One read, my lord.
Yes, very good. Because it's a cubic, which is degree 3, the fundamental theorem of algebra tells us that whatever the degree of the polynomial is you're dealing with will also be the number of roots, which is solutions or zeros or x-intercepts. So there will be 3 solutions here. And we've narrowed it down. We've got our factors here. This one is pretty straightforward. If this was 0, then x would have to be positive 6. This one here, we're going to have to set equal to 0 to see what actually happens, because it's not as nice as it looks. X squared is equal to negative 2. X would be the square root of negative 2, which we're going to call x is equal to plus or minus I times the square root of 2. You could also put plus or minus, here I'm going to just write it a slightly different way, plus or minus the root 2 times I. Okay? Those are your other 2 solutions. I just wrote them in 2 different ways. Both of them represent both solutions because of the plus or minus, which gives us 3 solutions, 2 of which are imaginary, 1 is real. One last little thing to throw in, imaginary solutions come in pairs because you're always going to end up doing plus or minus something. So they're always going to be in pairs of each other. plus or minus square root of 2 times I. Will be two solutions, and then 6 will be the other solution. Anyway, that's factor by grouping. That's how you can apply it to both quadratics and cubics. And that was all that Ring Matthews had to say. So, does anybody have any other questions? If you do, you should ask them. If you don't, then what would you even ask? I'm not going to tell you to ask them if you don't have them, because that wouldn't make any sense. Right? Right. Levi's there for me. Yeah. Very good. Very good. Very good. I want to be in a position someday where I can like give a speech while pacing back and forth. I guess I'd have to be like an army general. I guess teachers could do that. But it's much more of like a, gentlemen, you're going to war today. That kind of thing.
Well, imagine if you had to give that speech to the teacher.
To the teacher. Just one teacher seated, and you're somehow talking to the teacher like that?
Yeah, that's not what I meant. But it's about as useless. That's what I was saying.
Okay, yeah, that's fair. I expected nothing less and nothing more than pure uselessness.
This has been a very
Gentle.
satisfying erasing day. In my
Has it
opinion.
been?
Yes.
You know, I got this green marker that apparently I've never used before, and it feels good.
Yeah.
It feels good. Da 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 da.
In the neighborhood.
Hood. Our house in the middle of our street. Da na 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 na. Is good.
Fire.
The house is on fire?
No, it's an old Jewish communist song. I think.
That you learned at camp?
Quiet stream. It is a quiet stream, you're right.
It is a quiet stream.
Yes.
But you know what they say? Still waters run deep. A quiet stream, a babbling brook. A little creek in the forest. These are very gentle parts of nature.
Yes, and
We
we
should
are
make
gentle
sure-
parts of the SAT and ACT.
Yes, very much so. Humans are probably the gentlest parts of nature.
Yes,
Yes.
that's why we don't condone violence.
We absolutely do not condone violence. We don't condone it.
Very
No
soft
violence.
No, and
What do we not condone?
violence.
Yeah. Was that French?
Yeah,
Is that how you say it?
yeah. They all make fart
Spanish.
noises with their mouths at the end of their sentences.
Is that so?
Yeah.
That's
It's a
offensive.
Parisian thing. not
Violencia is how you would say it in
If you're
Spanish.
not good at French.
Yes, very true. And that's actually what most Spanish-speaking countries are, is they're all trying to get French.
Yes.
And they're failing in exactly the same way, so they understand each other.
Mm-hmm.
Yeah. A lot of people don't really realize that. Hey, Levi.
Yes,
This Alta Ipsum business.
Mhm.
What is that?
I don't know. I feel like Matthew might need to explain to us.
Matthew, Ring, what is Alta Ipsum? How can I get my hands on one? And what does it do?
Tell us, Matthew.
Yeah, I'm going to grab a little bit of water.
Can you fill up my water bottle?
Yeah.
Thank you. Not from your water bottle, necessarily.
Yeah.
Alta Ipsum. You know Alta Ipsum. Wait, it's not even here right now. It does your homework for you. Yes, it does all of your homework for you. It will get the worst possible grade on your homework, probably. But it will be there by your side with an encouraging presence every step of the way. And, you know, what more do you want? You should be doing your own homework. But Alta Ipsum will be there telling you to do it. So that's nice. If you want to do your homework then, but you're going to forget, you put it in your Alta Ipsum calendar. It'll send you reminders. It'll track your grades. It'll also say, okay, well, you got this big thing coming up, so here's going to be your study schedule. So it'll set up a study schedule for you. You don't have to do anything ever again. And that's what we're all after, is ease. Right?
Yes, convenience.
It's about ease and convenience.
Just sitting down and never having to get up again.
Yes.
Watching as your body deteriorates.
Yes.
Yes. Have you talked about it's free for the first month?
Oh.
Have you even said anything real about it?
You know I have.
Okay.
Yeah. You just heard the end and the beginning.
Okay.
But the middle was pretty legit. It won't do everything for you. You'll still have to do things. Well, I mean, having Alta Ipsum or not does not have any bearing on whether or not you need to do other things. So you could do nothing. if that's what you're into. But Alta Ipsum will do a great deal for you with regards to executive functioning and organizing your life and making you happier and more productive. But it's free for a month once you get it. It's free today, but you missed today, which is pretty sad. Okay, I'm going to see if I can pull something out from one of the other Discords.
Yay, you should do it.
Discord, my lord. Okay.
We should kind of darken our footage.
Yeah,
Yeah,
Is
they
it
can
bad?
see like the back corners of our curtain.
that's probably good though.
Why?
I don't know.
Okay.
Nope, that's not helpful. Nope. All right. Well, nothing big going on, Brady. We can talk about factoring recognition, because we know Brady loves recognition.
Well, it's the best part.
If you don't recognize that you're supposed to factor, it doesn't matter how good a factor you are. So it's also important to put factoring in context. By definition, factoring is breaking down some number or set of terms into pieces that when multiplied together will give you that thing. So when you have, we have x minus y, x plus y, and that equals x squared minus y squared. We know that. This is the factored form because it is two pieces it's just factors. It's things multiplied together. This is not factored because it's something minus something else. Now, yes, you have x times x, y times y, but you're subtracting. The operation that's connecting all the major pieces here is multiplication, and that is what factored form will look like. So when are you supposed to factor is more the question, and that is only sometimes. So people are used to seeing something like this and saying, oh, I need to factor. Or you're used to seeing something like this, x squared minus 2y minus 15. And you're told in school to do 1,000 of these and you factor them all. And you get very good at factoring, but you're not necessarily good at recognizing when you're supposed to do it. And that's very important because you might see something like this where you have, let's say, x minus y equals 15 over y. That doesn't make any sense. Let's say, that should have been an x anyway, x minus 2 equals 15 over x. So first of all, you need to recognize that you don't want an x in your denominator in this. So we're going to multiply both sides by x. We get x squared minus 2x equals 15. Now even here, you might not recognize that you're supposed to factor. When the way to recognize the necessity of factoring is when you're trying to solve for your variable and you have multiple variables, multiple instances of your variable, in this case x, and you cannot combine them. You can't combine your variable's terms. Clearly, we have x squared and we have 2x. Those don't go together, so you will have to factor. In this case, we would subtract 15 from both sides. Now we have it equal to 0. We can use the zero product property at the end, once we factor it, to figure out what values of x give us a value of 0 for this expression. This is not difficult math. Most people can do this by the time they're taking the SAT. They can do the literal factoring, but they might not recognize how to get there in the first place. One of the things in this problem was you had to realize you need to get your x out of the denominator because you don't like your variable in the denominator. Then here, you might not realize you should be subtracting 15 so that you have this, it's equal to 0, and you can do your factoring thing. It's also another time to factor is when you have something like this and they won't tell you to factor. It's seldom that you see the SAT, especially the SAT, say, hey, factor this thing. They won't do that. They might give you something like this. And they'll say, all right, here's our function. What are the x-intercepts? Well, x-intercept means that y has a value of 0. So you plug in value, you plug in 0 for that y, because f of x is y. And then you have 0 equals x squared minus 2x minus 15, which then you would see, oh, well, clearly I have to factor. But one of the other things is you can't combine your x terms, so you have to factor. That's the rule, okay? So when you can't combine your, in this case, we're going to say x because that's how we normally have our variable, x terms. It could be any variable name, it doesn't matter. As long as you know it's a variable, it's not a constant or anything like that. Okay, there's another thing. Hey, Brady.
Yeah.
You could actually solve something like this. This x squared minus 2x equals 15.
Minus 15, you mean? Oh,
Equals
no,
15
yeah.
with completing the square.
Oh, absolutely.
Which is kind of fun. So that's what I'm going to do right now.
It's going to actually turn out really well.
Is it?
Yeah.
Well, it's got to. I mean, the one I made is going to turn out well. So yeah. So we have x squared minus 2x equals 15. Now, rather than do normal factoring, we're going to complete the square, just with this piece. So we need to add, remember, we're adding b over 2 squared. b over 2 squared is negative 2 over 2, which is negative 1. Squared is 1. So we have x squared minus 2x plus 1 equals 15 plus 1. We added 1 to both sides. Now we're going to just factor this left side, and it will, and we don't even have to factor. You know that it's going to be x minus 1. It's always going to be b over 2. That will be your other side of the factor here. So we have x minus 1 squared equals, we'll add these together, 16. Now we'll take the square root of both sides. Make sure to do the plus or minus root, the positive and negative root. X minus 1 equals 4, or x minus 1 equals negative 4. Then we have x equals 3, or x equals negative 3. That didn't make sense here. X equals 5. Those are our two values. That seems to make sense because if we were going to factor this, we would get x minus 5 times x plus 3 equals 0, which would be x equals 5 or x equals negative 3. Either way works. This is pretty uncommon, people completing the square rather than just factoring straight up. Completing the square is much more useful for when you're not trying to solve, but you're trying to convert a standard form equation into a vertex form or the nice circle equation that you want to get a lot of the time. Helps you find the vertex, helps you find the center of the circle, that fun stuff. Okay, I'm going to erase this. Seems like nobody has questions here, unless that was just a question on my phone. It was not. Okay. Any questions on anything, or anyone, really? Why am I so sniffly, Bird?
Because of what's in the air.
Oh. It's not what's in my nose?
No.
Does anybody have any questions? We get worried if you don't have questions. Bird, do you have any questions for me?
Yeah.
Yeah? Okay.
Where do you get off?
Where do I get off? The question is not where, but when.
Mm.
And the answer is hopefully in half an hour after a huge slew of questions is dumped on us through Discord and the chat. But I find that unlikely based on how many people are asking questions and how many have in the last given period of time.
Yeah, do you want to call it?
We don't condone violence, by the way.
Yeah, that's good.
Do I want to call it right now? Not necessarily. Hey, Matthew, are you still here? Do you have questions?
Where are you, Matthew?
Ah, sequences and series. There we go.
All right, that's a big question.
Let's get into it.
Let's get into it.
You mind if I take this one?
Not at all. Here, I'll start making
Big time.
No, you should start on the.
Big time. On that side?
Well, I don't know. How are you gonna do everything? Are you gonna really go into it?
I'll start with sequences.
Okay.
The short answer, Ring, is that sequences are lists of numbers, and series are adding up the numbers in those lists. What is?
I couldn't find any reminders about numbers.
Oh, because I said series.
Call mom.
No.
Hey Siri. Call mom.
No, we're done. No, none of that.
Okay.
None of that. Okay.
Dang it.
So, Ring Matthews, let me give you an example of a sequence. You see where this is going. What am I doing in the sequence? What's happening? I don't know what's happening, and I'm scared. I'm scared, Matthews. Ring. I will not continue until you tell me what's happening, because I don't know what's happening. I just don't know. And then while you're thinking about this, all right, clearly you are doing your own thing, so I'll just tell you. We're adding 5 every single time. We're adding 5 from term to term. This one here is a different situation. We're multiplying by 2 every single time, all right? These are our 2 basic sequences that you're going to see on the ACT and SAT. There's an infinite list of different kinds of sequences and series. There's all sorts of different rules you can implement. But the ones you have to understand, like the back of your appendages, is an arithmetic sequence, which is when you're adding or subtracting something, or a geometric sequence, which is when you're multiplying or dividing something. So to be a little bit more general, with arithmetic, really you're adding something every single time. If the numbers are going down, it's because you're adding a negative number, which is the same as subtraction. With geometric, you're multiplying. You could think of it as dividing. So if I gave you one that looked like this instead. So we had like 9, 4.5, 2.25, 1.125. You see where this is going. Anyway, we are dividing by 2 every single time, which can also be thought of as multiplying by 1/2. So whatever you're multiplying by, we call that the common ratio in geometric sequences. So times r, that looks like an x. Here we go. R, the common ratio. In this case, r is equal to 2. In this case, r is equal to 1/2. And then up here, we have d, which is the common difference. Ring Matthews, are you still here? Are you still here, Ring Matthews? We need you. You are our only hope. So in this case, our common difference is 5, because we're adding 5 every single time. Okay, good. So these right here are sequences. They are sequences. Arithmetic sequence and geometric sequence. Series are where you add up terms in those sequences. So for instance, let's say I called this sequence up here a sub n, okay? So this is an arithmetic sequence, and the sub n tells you the position in the sequence it is. So for instance, a sub 1 is the first position of that sequence, which we know is 4. A sub 2 is the second, which is 9. The pattern for this would be a sub n is equal to, I guess this would be 4 plus 5 times n minus 1, okay? This is like, it's basically like slope-intercept form. We're starting with 4. That's our very first term. And then we're adding 5 times some multiple. So for our very first term, n is 1. We plug 1 in here. This turns into 0. 5 times 0 is 0. So we're just stuck with 4. That's how we get A1 being the right starting point. And then we put in A2, we end up adding 5 one time, and so on and so forth. Okay? So that is the definition. That is what's called the explicit formula of this sequence. If I wanted to take the sum, there's two different kinds of sums you can take. So you can take the partial sum, and that looks like this. Is that, Levi, partial sum, is that you just say S5?
Yeah.
I think so. This would be a series where you're trying to find the sum of the first 5 terms, which we have written out on the board. So this would just be you're adding the first 5 terms in that sequence, and that is what is called a series. I do not know why they called it that. I find it rather confusing because a series of events is a bunch of them in a row, and a sequence of events is a bunch of them in a row. So it's just kind of math speak. Add those together, you get a number. There you go. All right, that's called a partial sum because it doesn't add up all the numbers in the sequence. There are technically an infinite number of terms in the sequence because this formula allows you to put whatever number in you want for n. So you will not be able to find what is the final term because it's just infinite. All right, so really all you can take is a partial sum. Geometric's a little different. In this case, we're multiplying by 2 every single time, so our terms are getting bigger and bigger. So there's no way we can get an infinite sum here. Or, I don't know, a partial sum is, and then there's a, Levi, vocab, the series of the entire sequence. It's not a partial sum, is it just a full sum?
What is this?
Series, so like partial sums, and then if you take the sum of the entire sequence. Is that just big S?
Infinite sum?
That's just big S. Okay. So in this case, you would not be able to take the sum of this first geometric sequence because it's going to what's called diverge, which is it's going to get bigger and bigger. It's not going to zoom in on a certain number. But this one actually will, because our numbers are getting smaller and smaller. So it actually turns out that as you keep adding numbers here and they keep getting smaller, you will move toward a very specific number. And this is how you calculate it. There is some math involved in deriving this formula, but it is the first term divided by 1 minus the common ratio. So our first term here is 9. Our common ratio is 1/2. So we're going to take 9 over 1 minus 1/2. Get us 9 over 1/2. 9 divided by 1/2 is 9 times 2, which is 16. So if you keep writing out terms, you're going to see them get smaller and smaller. If you add them all up, you will approach 16. Technically, you're adding terms forever, but you're going to get so close to 16. Just a little example. Let's say that you want to. Let's say that this whole thing right here is 1 unit, and we keep taking halves of what we have. So, like, let me give you an example. Let's say first we go halfway there. So we've now covered half of it. Now let's cover the next half of what's left. If we go half, that'll be 1/4. So now we're 3/4 of the way there. Now let's take another half of what's left, which will be 1/8. So now we're 7/8 of the way there. Okay. If we keep going this way, we're going to have 15/16. We're going to have 31/32. We're going to have 63/64. You're going to get closer and closer to 1. All right, and if you add them all up infinitely forever, you'll get to 1 if you add up all the terms infinitely. So there is a convergence here. It's getting closer and closer to 1. So you can take the sum of a sequence that's geometric if and only if your common ratio is less than 1. If your common ratio is less than 1, then your terms are getting smaller and smaller, which is what you want if you want to be able to add them all up. They're bigger. If the common ratio is bigger than 1, then the numbers are going to keep getting bigger and you won't be able to add them up because it is going to diverge. Oh! Ring Matthews, does that answer your question? That is what they are. There are certain things they'll expect you to know how to do, but that is what they are in a nut shell, the shell of a nut inside of that shell. Yes, you're welcome. You're welcome. Levy. What can I say except you're welcome? I'm the rock. Have you noticed how jacked the rock is?
No, I think you're alone in that.
judgment call. Yeah, I might be. Maybe I'm crazy. Maybe I'm a dreamer. I'm the only one who thinks that the rock is jacked. It's kind of sad. I'm alone in my beliefs. Anyway, if we got no more questions, I think Levi and I will probably
Matthew's grammar.
direct inverse variation. Yes, we can talk about that. Ring, where are you getting these? I mean, these are all good concepts, but you just have a list of like the right things to ask about. Where is this list coming from?
Don't tell him.
Did you give him this? Did you? To ask us?
No, not to ask us.
Okay.
We can talk about it later.
Okay. Oh.
It's fine.
You gave him the list.
Yeah.
Okay.
Not like I copied and pasted like math, not in the order that we have, not with numbers, just like
Okay.
the words.
Gotcha. All right. Well, then, okay, you gave him the list. You can talk about direct and inverse variation.
This is good, Bert.
This is a good thing.
You don't want to talk about it?
You can do it, dude.
Oh,
Ah.
I thought you liked teaching. You don't teach enough today. You didn't teach enough. Don't do that. Okay, direct. The list you have is it is our full list. There's just some information that's left off of it, but it's all the things that I would never teach anything that's not on this. There are specific approaches to question types that aren't on that because it's just the list. Okay, so direct and inverse variation. This is a concept that these are concepts that you know. It's just the way we're titling it there. So this just means as one thing goes up, then the other thing goes up. This is on the science section of the ACT a lot. It's not on the SAT really. I guess, is there direct and inverse variation on the SAT graphs and stuff?
Yeah, sometimes. As far as graphs, it's usually just if weight varies with this and varies inversely with this, what's the equation?
Yeah, so let's say we have something like SAT score here on this axis, and then we have number of hours studying. So this is what's happening, and let's say it probably looks something like that, right? That's your graph of, if you study more, you will have a higher SAT score than you would have otherwise, right? You also need to add a margin of error and sample size. Yes, I think that's probably included in some, but yes, you're right. Yes, from what I took. Yeah. Okay. So this is stuff you probably know, Matthew, so let me know if you don't, and then we can go in more in depth. But direct variation is what this is. The number of hours studying goes up. If this goes up, SAT score goes up, right? They vary directly with each other. When one goes up, the other goes up. When one goes down, the other one goes down.
It's
Right?
gotta go through the origin. It's gotta go through the origin. Y equals kx.
Oh, yeah. Okay, so through the origin. The big origin. All right. So this is direct variation. Indirect variation, or sorry, not indirect variation. Inverse variation is something like supply and demand. Does that work well enough for the general purposes of this?
I mean, are they curved or are they like?
I mean, it depends on the actual situation. But as supply goes up,
as price goes up.
price. Yes.
Yeah.
Let's do price and consumption. So price and purchases. So for some product, it doesn't matter what, let's say private tutoring. As you raise the price on private, well, actually, that's not actually a good example, depending on where you are. Let's say you're selling a marker, and you're selling the marker for $1. So if you sell the marker for $1, you're going to, there are going to be a certain number of purchases of that marker. Let's say it's here. Obviously, this is super vague, so let me know if you want actual examples of numbers that are totally made up too. This is not a good place to start it. Let's say you buy a lot of markers at $1, but if you sell them for 50 cents, you're probably going to sell even more. But if you sell them for $10, it's going to be down here. So this is inverse variation.
No, wait.
Graphically, roughly.
It's not going to be a. It's not going to be a slant. I mean, it's going to look like this. There's
Yes.
two equations you have to know for direct and inverse variation. Direct
Equation is
variation
yes.
looks like this. Inverse variation looks like this. So anything that basically looks like slope-intercept form, except there's no y-intercept, it's just a slope, is direct variation. If you're buying burgers and each one is $2, then you just say, the price in total is going to be 2 times the number of burgers. So if you buy double the burgers, then your price is also going to double. And then as long as this thing is curved.
You're ignoring the ends, the extremes here, because that's when things get funky. But yeah, and generally they'll give you graphs that are bounded with domains so that it's not going to be super weird, or you'll have to deal with it with equations, but it's more about recognizing things. So, Durander, hello. We love you too. If y varies directly as x.
I don't know why they say as, but they do sometimes.
They say that.
Okay. Here's an
I'm
example
going to
of.
erase these two.
Okay. All right. Knowing this equation here for direct variation is what you need to understand this question. If y varies directly as x, which means direct variation, and y is 20 when x is 5, what is y when x equals 30? We have one pairing we know for sure, which is y is 20 when x equals 5. So you want to set up your direct equation here, y is equal to kx, and first figure out what is that constant of proportionality. That's what the k stands for. You're going to put 20 in for y. So that's equal to k times what the x value is that you know, which is 5. So some simple algebra, you will figure out that k is equal to 4. So now we have our general proportionality equation, which is y is equal to 4x. So the question is, what is y when x is 30? We just plug in 30 for x.
Durander, do you have any questions? If you have any questions, put them in chat, put them in the Discord, do that stuff.
That would be how to solve a direct variation problem. I don't think they usually give you graphs for these.
I've seen
problems.
tables.
Okay.
It's more about the general understanding of when one goes up, the other goes down, and vice versa. I've seen this, but they'll give you this equation. They'll say there's they'll say this is the equation, and you have to find what k is, and then use that. But I've only seen it when they give you that equation. It's good to know them. I think they really follow from understanding what's going on anyway. But this is direct and inverse variation. Matthew, do you have any questions on that? Does anybody else have any questions on that? Or questions on anything? Bird's life, which is very personal.
My life. He says
Okay. That's very...
Ring has the full list. So, this could go on
Well,
forever.
literally forever.
This
and
could
ever.
go on forever.
Yeah.
You don't realize what you've done.
I know exactly what I've done.
No, you don't. You don't know anything about what you've done.
I have no idea. You're right. All right, we have 9 minutes. So Matthew, if you've got another question, great. If not, also, well, no. If not as great. Other people too, definitely ask questions. Please. It's pretty hot in here, so if you want to make Brady put on the circumference outfit, just call for it and he'll do it because he can't stop.
I wouldn't like that at all.
Oh. Wait, was there another? Bum, 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 ba-dum, ba-da-da-da-da-dum-da-dum.
Hey.
Okay. It seems like if nobody, so please ask us questions. We'll give you another minute. We have another 8 minutes until we're going to be done. But if you have a question in the next minute, please ask it, and we will do that. We'll talk about it. We'll do it. Don't think we won't. Brady thinks we won't, but I will prove to him otherwise.
I don't think we will.
You don't think so? Okay. Seems like nothing. I mean, we have people are watching. You're just watching me flounder. Don't really have questions. Yeah, that makes sense, Matthew. I mean, you know most of the stuff you need to know. It's just for you at this point. It's practice and practicing doing it right every time, not making mistakes, knowing exactly why all the wrong answers are wrong. If you can identify why wrong answers are wrong, not only are you going to be very good at the test, maybe get a perfect score, but you can basically tutor. That's kind of the understanding necessary to be able to start teaching, is knowing why everything is wrong, so you can answer any question. Except for, do you have any questions? Okay, I think we're done for tonight. We're going to be back tomorrow. We'll do some specific writing stuff, probably. Brady was going to... Ow!
We don't condone violence.
I heard that, and I felt the opposite. Okay, have a good night, everybody. We will see you tomorrow, unless anybody has questions. Nobody has questions. Nobody has questions.